All right, let's jump right in. Today, we're tackling NCP-MCI 7.5, specifically Section 13.4, Network and Container Mapping for Failover. This is a massively testable area for the Nutanix certification, mostly because it bridges that gap between theoretical data protection and actual functional disaster recovery in AOS 7.5 and AHV 11.0. We are going to unpack exactly what happens to your virtual machines when they move from a primary site to a recovery site, and more importantly, how to configure things so those workloads actually function the absolute second they power on.
Here is our roadmap for today. We have 4 main stops: why mapping matters, a walkthrough of networks and containers, those tricky common exam traps, and finally, the key facts you absolutely have to memorize. Okay, part 1. Why mapping matters, the foundation of disaster recovery. Before we get into the weeds, let's just make sure we're speaking the exact same language. We'll be throwing around terms like DR for disaster recovery, VM for virtual machine, VNEC for virtual network interface card, and NGT, which is Nutanix guest tools. That VNIC is super important here, right? Because a VM without a virtual network interface card is basically just a disconnected island of compute. It can't talk to anybody. We'll also touch on NGT later, which is going to be your best friend for advanced IP configuration during a failover. Now, the real linchpin here is IPAM, or IP address management. This is a foundational concept you just have to grasp for the exam. In AHV, a network is considered a managed network if IPM is enabled, and unmanaged if it's not. The huge takeaway here? IPAM is managed centrally by Prism Central. The AOS leader grabs an IP address from a pool when a managed VM NIC is created and chucks it back into the pool when it's deleted. Just keep that strict separation of management in mind. Prism Central is calling the shots here, not the individual clusters. This is going to be the source of our biggest exam trap later on.
To see why all this matters, picture this. It's 2 a.m., disaster strikes, and you trigger a failover. If you set up network mapping correctly beforehand, your VM wakes up on the new network, keeps its VNIC, gets an IP, and boom, users are back online. But what if you didn't configure mapping? Well, the storage fails over fine, but the VM powers on with absolutely zero network configuration. You'd open the console, see the OS humming along perfectly fine, but there are no network devices attached. Your VM wakes up in a new data center completely deaf and mute, totally cut off from the world.
All right, moving on to Section 2, Network and Container Walkthrough, focusing on the actual mechanics and examples. So how do we actually build this out? Network mapping is fundamentally a layer 2 process, and there's a very specific sequence. Step 1, you have to create your networks and VLANs on both the source and the destination clusters ahead of time. Step 2 is absolutely critical. You configure the network mapping on both of those clusters. You have to do this bidirectional mapping to guarantee that VNIC gets created on the failover VMs. Why both sides? Because failback is just as important as failover, right? And finally, step 3, you configure your storage container, or vStore, mapping. Let's make this super concrete with a couple of examples for the exam. On the network side, let's say you map VLAN 01 on your primary site to VLAN 02 on the recovery site. When a failover happens, a VM sitting in VLAN 01 automatically and seamlessly wakes up in VLAN 02. It just works. For storage, if your protected entities live in a container named self-service container on the primary, Nutanix will immediately look for a container with that exact same name on the recovery side to drop the data into. Let's dig into that container mapping a bit more, because the underlying logic is really important. During that first replication, or initial seeding, Nutanix automatically maps to a container with the exact same name. It's incredibly efficient. But what if a container with that name doesn't exist over there? Well, it falls back. It might drop the data into a random container, or if unmapped in a primary to remote setup, it defaults to the remote site's self-service container. Obviously, you never want surprises during a DR event. You don't want some random container filling up, so explicitly configuring this mapping yourself is 100% the best practice. Now listen up, because this next part is a massive administrative trap heavily documented by Nutanix. If you decide to go in and change a vStore mapping after the fact, like tweaking it weeks after your DR is already set up, it forces the associated protection domains to initiate a completely full replication to the new target container. It treats it exactly like day 1 initial seeding. You are going to chew up tons of storage resources and probably crush your WAN link. If you absolutely have to reconfigure a vStore mapping, you need to first delete or unprotect the vStore, make your change, and then protect it all over again. Let's roll right into Section 3, Common Exam Traps, specifically the IPAM limitation. Okay, here is the absolute biggest trap on the exam, hands down. We established earlier that IPAM is run strictly by Prism Central.
Because of that, traditional Prism Element-based protection domains absolutely do not support network mapping for VMs on IPAM-managed networks. Prism Element is basically flying blind here. It just doesn't have the visibility into the Prism Central database to make that mapping happen for those virtual machines.
If you ignore that limitation and try to map an IPAM-managed network using a Prism Element protection domain anyway, you are going to hit a wall. You'll get this exact persistent alert: invalid network mapping specified for remote site. Seeing that pop up during a high-stress failover test is definitely panic-inducing. The exam might literally ask you what causes this specific non-critical alert. The answer: attempting to map an IPAM network using a legacy protection domain structure. So what's the architectural fix when you run into this? You have to pivot your strategy. To protect VMs on IPAM-managed networks, you absolutely must use protection policies which are natively managed over in Prism Central. Alternatively, if your organization forces you to use Prism Element protection domains for some legacy reason, you can only protect VMs on non-IPAM-managed networks. Knowing that hard boundary between Prism Element and Prism Central capabilities is make or break for the test.
Besides the IPAM stuff, watch out for static IP mapping edge cases. If your DR plan requires specific per VM static IPs upon failover, there's some very strict prerequisites. First, Nutanix Guest Tools, NGT, has to be installed on the VM. Second, and this one catches people out all the time, the protected VM must have at least one empty CD-ROM slot. Seriously, an empty CD-ROM slot. That's because the system actively needs it to mount the NGT ISO at the recovery availability zone so it can securely inject the new IP config. Oh, and specifying the CIDR in the recovery plan becomes totally mandatory for this to work.
There's one final edge case you need to be aware of. If you happen to be running ESXi instead of AHV, Nutanix data distribution inherently does not support mapping the nodes of a single Nutanix cluster to multiple split vSphere clusters. If your underlying ESXi nodes aren't perfectly aligned and situated in the exact same vSphere cluster, your disaster recovery operations, migrations, recoveries will just fail out. All right, let's bring it home with Section 4, Key Facts to Memorize. This is your cheat sheet. If you forget everything else from this explainer, write these 4 non-negotiable facts down. 1. Network mapping is strictly Layer 2, and without it, your VMs are going to fail over without a network card, rendering them totally useless. 2. For automatic container mapping to work smoothly during initial seeding, the containers have to have identical names on both sides. 3. Our golden rule: Prism Element cannot network map IPAM-managed networks. You absolutely have to use Prism Central Protection Policies. And 4. If you want static IP mapping injected on failover, you must have NGT installed and leave an empty CD-ROM slot on the VM. I'm going to leave you with a quick scenario to test yourself. If you suddenly see an invalid network mapping specified for remote site alert for a VM in a protection domain, which management plane do you need to jump into to fix your protection strategy? Well, if you remember where IPAM authority actually lives, you know exactly what to do. Get that down and you are totally ready for the network mapping questions on the NCP-MCI 7.5. Thanks for joining me today and best of luck on your certification journey.